Okay, now again, collision in 2 dimensions. 2 kilograms at 5 meters per second, 3 kilograms at 4 meters per second. And the angles are such that the components are V1 equals 4 meters per second times I plus 3 meters per second times J. Now if I gave you this velocity, or this speed, and an angle with respect to a positive x-axis, then you could just use the sine and cosine of the angle to get these components. So if you're given that information, you can always get this information. I'm bypassing that. That's very straightforward, and I'm just going to specify I and J components. So you can figure out what angles I have in mind. And then over here, similarly, if you had the angle and magnitude of the vector, you could calculate the components. I'm just inserting the components. Okay, so what's P1 and P2? Okay, P1 before collision is, well, two kilograms times V1, which is going to give us 8 kilogram meters per second times I, plus 6 kilogram meters per second times J. Here we've got 3 kilograms, so we're going to have to multiply V2 by 3 kilograms. And that's going to give us negative 7.2 kilogram meters per second times I, plus 9.6 kilogram meters per second times J. So that P1, I'll write TOT for total. Your text might have done that, I don't remember exactly. Okay, P1 total is what? Well, we add the I components and we add the J components. The I components add up to, hard to write that 8 down here, 0.8 kilogram meters per second times I, and 15.6 times kilograms meters per second times J. That's your total momentum. Okay, well, let's say this is a situation before. Then here's our total momentum before collision. Now we want to get the total momentum after collision. What's that? Well, it's going to be the same. Okay. Now we don't have a lot of information, but now let's suppose that V2 after collision is, okay, let's see what's reasonable. Let's say if that thing hits at this speed, this thing hits at this speed, and that thing could go off in that direction. And let's just say that it's 3 meters per second times I plus 4 meters per second times J. Now that's totally unrelated to the fact that you got 4 here and 3 here. That's just another coincidence, except it's not really a coincidence because those are easy numbers that seem to kind of fit here. Okay. Then the momentum of the second after collision, I haven't left myself a lot of room, so I'm going to have to write small, is going to be, we got 3 kilograms. So you have this. Thus, when I wrote this, it's true. Except I was careless with my subscripts. What I meant to write here was that the total momentum before equals the total momentum after. So total momentum after equals total momentum before. And our conclusion then is going to be and here I wrote P1 total. That should be P before total. Okay. So here's your total momentum before collision, and that has to equal your total momentum after collision. And now we're going to write that out. Okay? And to repeat it, we have this expression, and I don't want that expression on this side. A little attention to detail. Wouldn't hurt anything. Okay. The total momentum after is going to be P2 after plus P1 after. So I guess I better maybe go ahead and write it out like this. P1 after plus P2 after equals P1 before plus P2 before. So the totals before and after are equal. So that P1 after is your mass of the first, which is 2 kilograms, times V1 after. P2 after is nine kilogram meters per second I plus 12 kilogram meters per second times J, and that's equal to total momentum after, which is 0.8 kilogram meters per second I plus 15.6 kilogram meters per second times J. Well, now we can simply solve for V1A. We can subtract the 9 kilogram meters per second I from the 0.8 kilogram meters per second I. And we get negative 8.2, I want to say 7.2, negative 8.2 kilogram meters per second. Then we've got to divide that by the 2 kilograms. And that's times I. And then we're going to subtract the 12 kilograms meters per second from the 15.6 kilogram meters per second, getting 3.6. Kilogram meters per second times J, which we have to divide by the 2 kilograms. And we get negative 4.2 meters per second. Yeah, I guess that works. Times I plus 1.8 kilogram meters per second times J. Now when I compare that to my intuition of this collision, I kind of don't believe my result. The procedure is correct. But something about this is kind of disturbing. We have I'm thinking this could be okay because you got a lot of momentum in this direction from that ball, not as much from this one. But I don't think this is going to rebound that quickly. So I've got some kind of a bug here. I'm not going to worry about it. You might want to work it through yourself, see what's wrong. The point, though, is just writing all this out with I and J components works out just fine. Now your book will probably, in the examples I think I saw when I took a quick glance, and it's hard to take a quick glance of an e-text, but when I took a quick glance, they might well separate it out into X and Y components. So I'm going to go ahead and do that. We could as well said that X components are I'm getting carried away with subscript, but PBX total is negative 0.8 kilogram meters per second, which is calculated just by ignoring all the J components and figuring out all the I components, or all the X components. And going to call that V1x after, whatever order you want these in, and I'm not being real consistent about that. So I left the 9 kilogram meters per second off there. So I change my equal sign to a plus. Get rid of that minus and that decimal. Make that 8 into a 9. And this equals your negative 0.8 kilogram meters per second. Okay, well, that's just part of what we got up here, or what we got down here. The I component has to equal the I component. You separate it off and look at it separately. Then you do the same for the J component, and you work it all the way through. You do it either way. I kind of like this better, but whatever works better for you, one is equally, more or less equally, as good as the other. Okay, so there's a collision in 2 dimensions. And you can look at examples in the text if you haven't already. And there you pretty much have it. Okay.